8:32 a.m. The alarm at Joint Base Elmendorf-Richardson is still echoing when the lead F-22 Raptor surges off the runway and climbs hard into the Alaskan sky, pulling a brutal 9G ascent that tears through the morning calm. There is no time for a slow introduction. Just 400 miles out, two Russian Tu-95 Bear H strategic bombers and a pair of Su-35 Flanker E escorts are already moving into the Alaska Air Defense Identification Zone. These bombers are built to carry KH-101 cruise missiles, low-flying long-range weapons designed to travel deep before being detected. American pilots push their throttles forward and race to intercept the formation before it can reach a possible launch position. At the edge of the world, two major powers are now closing fast, but this encounter really started more than an hour earlier, far below the clouds. At 7:15 a.m., the USS Hopper, a 9,000-ton Arleigh Burke-class guided missile destroyer, was cutting through 10-foot Arctic swells in the Gulf of Alaska. The ship was not simply on patrol, it was already hunting for information. Its SPY-1D phased array radar, the core of the Aegis combat system, was pushing through Russian electronic interference and locking onto the incoming aircraft while they were still over international waters. Altitude, speed, heading, every detail was captured. Instead of just observing, Hopper's crew pushed that data through Link 16, a secure tactical network that functions like a battlefield-speed internet connection. By 7:45 a.m., the Aegis system had already passed a fire control quality track to NORAD headquarters. That gave American forces roughly a 90-minute advantage to position assets and shape the response. The USS Hopper was not just watching the Russian aircraft. It was boxing them in digitally, working with Space Force satellites to make sure the Tu-95 bombers could not slip behind the curvature of the Earth and disappear. Inside the ship's Combat Information Center, sailors were already running SM-6 engagement simulations, calculating where an intercept would happen if the bombers opened their bays. By 9 a.m., the airspace over the Bering region had become a tactical chessboard. An E-3 Sentry AWACS cruised at 30,000 feet, its APY-2 radar rotating overhead like a giant searchlight. It was not merely monitoring the scene, it was directing the F-22 Raptors into a stealth pincer. The Tu-95 bombers were easy to hear, their massive NK-12 turboprop engines producing such a distinct acoustic signature that they could be detected far beyond the airspace around them. The Su-35 escorts, however, were trying to work the edges of the fight, using passive systems to search for the American fighters without revealing too much themselves. The F-22s answered with silence. At 9:12 a.m., the lead Raptor pilot rolled into a split S, diving out of the sun and sliding into the blind zone behind the Russian fighters. He still had not activated his own radar in a conventional way. Instead, he was taking in a live stream of targeting and tracking data from the AWACS and the USS Hopper directly through his helmet systems. The F-22's APG-77 AESA radar operated in low probability of intercept mode, changing frequencies so rapidly that Russian sensors would struggle to separate it from background noise. The Russian pilots scanned the horizon for a target that seemed absent, unaware that the Raptors were already in a dominant position behind them. At 9:15 a.m., the American pilots armed their systems. Digitally, they had all four Russian aircraft locked. The F-22's electronic warfare suite was already building profiles on the Russian aircraft, cataloging their radar behavior for future use. The Russians were flying into a layered trap, and every move they made was being answered by an integrated network they could not fully detect. The first real shock for the Russian crews came at 9:20 a.m. Without a clear warning, two F-22s suddenly appeared on their wing line. It looked almost unreal. The American fighters had used their low observable design to close the distance without being picked up early, then moved into visual range with precision. The Raptors held a controlled high angle of attack position beside the turboprop bombers, using thrust vectoring to make the point unmistakable. They had been there, unseen, and the Russians had never realized it. Every American fighter on station was carrying serious reach. Each F-22 had 6 AIM-120D AMRAAM missiles tucked inside its internal bays to preserve stealth, plus 2 AIM-9X Sidewinders for close-in work. The AIM-9X, with off-bore sight targeting, meant a pilot could engage simply by looking through the helmet system, even if the aircraft itself was not pointed directly at the target. The advantage was not just firepower, it was timing, geometry, and control. By 9:35 a.m., the Su-35 pilots tried to get more assertive, banking toward the Americans to test their reactions and maybe force a change in formation. The Raptor pilots did not bite. They used the F-22's superior agility and clean aerodynamic profile to remain in the most advantageous position behind the Russian fighters. The Su-35 is a formidable aircraft with powerful engines and advanced maneuvering capability, but external tanks and missiles were costing it performance. The F-22, with everything carried internally, remained fast, smooth, and difficult to counter. American communications stayed disciplined and minimal. What stood out was not drama, but efficiency. While that aerial standoff unfolded, the Navy was adding a powerful second layer from the surface. At 9:45 a.m., the USS Hopper and the USS Kidd had their Mark 41 vertical launch systems on elevated readiness. Each destroyer represented a highly capable multi-domain defense node. If the Russian bombers had launched a KH-101 cruise missile, the ships were ready to respond with the SM-6, an interceptor built to handle everything from fast-moving cruise missiles to terminal-phase ballistic threats. Because of cooperative engagement capability, Hopper could have launched using targeting data from the AWACS, engaging a threat long before its own radar had line of sight over the horizon. Below the surface, another piece of the puzzle was already in motion. At 9:50 a.m., a P-8A Poseidon maritime patrol aircraft was circling about 50 miles away, dropping SSQ-53G sonobuoys in a pattern to make sure no Russian Borei-class submarine was trying to use the air encounter as cover to move into a more dangerous position. The Poseidon carried Mark 54 lightweight torpedoes, and its APY-10 radar was searching the surface for any sign of a mast or periscope. The Russians were not facing just fighters overhead. They were facing a coordinated wall of sensors and response options, stretching from the seafloor to the upper atmosphere. The coordination was so tight that the P-8A could pass acoustic data to the USS Hopper, which could then feed the bigger picture back into the air battle. At 10:15 a.m., American endurance became the next advantage on display. A KC-135 Stratotanker met the F-22s over the Beaufort Sea for mid-air refueling, with KC-46 Pegasus support ensuring the operation could continue as long as necessary. The Raptors could remain on station far longer than most aircraft if fuel kept coming. It is expensive to keep an F-22 airborne, but the payoff in a moment like this is obvious. For the cost of a single major operation, the United States had shut down a strategic pressure move before it could achieve anything meaningful. That is where the economics of power become impossible to ignore. For a relatively contained operational cost, the U.S. demonstrated that a Russian strategic bomber patrol could be tracked, managed, and turned away without letting it dictate the pace. Critical Alaskan infrastructure, shipping lanes, and regional airspace remained secure. The two 95s, costly to maintain and operate, were forced to reverse course without completing a single objective. Their cruise missiles never had a realistic chance to become part of the story. This was not only a military success, it was also a signal to anyone watching that the Arctic trade and energy corridor remained protected. The human skill inside that machinery was just as impressive. At 10:20 a.m., the KC-46 boom operator guided the refueling connection with extraordinary precision, while the aircraft moved through Arctic turbulence. That allowed the F-22 pilots to stay focused on the Russian formation even while taking on fuel. It looks seamless, but this kind of coordination is demanding even in calm conditions. In a live intercept environment, it becomes a masterclass in discipline. At 10:45 a.m., the Russian bombers finally banked west and headed back toward the Russian Far East. The F-22s shadowed them until they were well outside the ADIZ, making sure there was no late-stage provocation or sudden maneuver. Even as the Russian aircraft pulled away, the AWACS and the USS Hopper continued tracking them for another 300 miles. The system did not stop working just because the danger was decreasing. It kept collecting. That brought the operation to one of its most valuable outcomes. Using its electronic warfare suite, the USS Hopper recorded radar signatures and radio frequency behavior from the Su-35s. This is electronic fingerprinting, and it matters. Every radar has its own rhythm, repetition, and output pattern. By gathering that data at 10:55 a.m., the Navy added another layer to its understanding of how specific Russian systems operate in real conditions. That information would later be fed into intelligence databases and used to refine electronic countermeasures across the fleet. In other words, the Russian aircraft did not just fail to gain leverage, they also revealed useful technical details in the process. By 11:30 a.m., the F-22s were back on the runway at Elmendorf. The flying was over, but the real analysis was only beginning. The lesson from the encounter was clear. In the Arctic, information speed decides everything. The U.S. Navy and NORAD showed that the northern approach remains heavily watched, tightly connected, and difficult to surprise. Even in one of the most remote regions on Earth, American systems can combine into a shared picture so complete that an opponent has almost no room to act unseen. And still, the most impressive element was the people inside the network. The F-22 pilot was not just flying. He was managing streams of information, tactical timing, positioning, and system inputs while pulling extreme G-forces in a freezing cockpit. The sailors aboard the USS Hopper were not simply standing watch. They were processing signals, building track quality, coordinating with multiple platforms, and helping shape the entire encounter in real time. That professionalism is what made the outcome feel so one-sided. Meanwhile, the Russian crews headed back to base, having to explain how a formation worth hundreds of millions of dollars was controlled by a network they could barely perceive. This intercept did more than secure Alaskan airspace. It sent a message to every serious military observer watching the Arctic. Challenging an integrated U.S. air and naval system in that environment means facing sensors that connect faster, track deeper, and coordinate more smoothly than most rivals can match. From the moment those Russian engines powered up, the formation was already moving inside an American tactical web. Now imagine you are the tactical action officer aboard the USS Hopper. It is 9:30 a.m. The Russian bombers are already tracked on your Spy 1D radar. Then your sonar team reports a fast underwater contact that could be a Russian Burai-class submarine, using the air intercept as cover to move past your position. At the same time, the E-3OAX reports that one of the Su-35s has turned toward the F-22s and activated jamming. Your Link 16 bandwidth is limited. Do you prioritize sending submarine targeting data to a P-8 Poseidon, or do you dedicate electronic warfare support to help the F-22s cut through the Su-35's interference? If you downplay the submarine, it could move into a far more dangerous position. If you downplay the jamming, the F-22s could lose their tactical edge and face a much more complicated close-range encounter. Do you split the response and accept reduced effectiveness in both areas, or commit fully to the air picture and assume the submarine contact is a distraction? How would you manage the chain of decisions when every second matters? In today's world, the side that wins the invisible contest is usually the side that processes information faster than the other side can react. The Tu-95s and Su-35s came looking for an opening and instead met a layered network that left almost no room to operate. In the Arctic, coordinated American air and naval power continues to set the pace, keeping the northern approach secure and showing that control of the sky begins long before anyone sees the aircraft. This scenario is a technical and tactical analysis inspired by real intercept activity involving Russian aircraft near Alaska. It draws from real-world military platforms, known capabilities, and regional tensions, while the exact sequence of actions is presented as a hypothetical dramatization to illustrate U.S. Navy, NORAD, and Joint Force doctrine in a high-pressure defense situation. Until next time, stay sharp and keep your eyes on the horizon.